And then once you've done your cutting, now you've actually sort of textured the inside of your object and the outside simultaneously. And again, a lot of this is possible because of how consistent and accurate our Boolean operation actually is. So here's like a horrible example for a Boolean, right? We're just taking all of these boxes and we're animating them together, and we're doing a Boolean union on all of the boxes. And on the right, we just cut the top off so you can see what's happening sort of inside this piece of geometry. So this is kind of a worst case scenario for a Boolean, right? Because all these faces are exactly the same plane, right? So it's almost like a two-dimensional Boolean of all these faces. And you can see how perfectly smooth it is on the right. Like when we put these boxes together, the edges, there's no flickering, there's no sort of abnormalities in the mesh. Everything is perfectly consistent and smooth, which is really absolutely necessary if you're going to use this as a procedural modeling tool. And by the way, these little green lines that are showing up here, these aren't just visualizations for you to see what's happening. That's data that Houdini is going to use. And so you can actually take that data and do extra operations after the Boolean. So here's a very simple example. We have these sort of objects, they're coming out, they're animating, and we're going to do a subtraction. And you'll see that green line. And so here's the same thing with the green line being used as a polybevel afterwards. So we're beveling the edges that are created by the Boolean operation. And this is all happening procedurally, right? Like I don't select edges, I don't have to go in there and select these things. The Boolean node actually generates the data and passes it downstream for you to use in different cases. So again, here you can see just nothing happening. Here's the visualization of the Boolean, and now those green edges on the outside have been used to bevel the edges to smooth that object into the surrounding geometry. So you can imagine now, this is animating, these objects are passing through each other, and it's still completely consistent. There's no jittering, there's no sort of odd things happening in the mesh. And so let's look at a more sort of complicated example. So this horse head has got about 200 and something thousand polygons in it. Each one of those starfish is around 10,000 polygons. And we're able to take all that geometry, that insane amount of geometry, and do a very clean union operation on them. And you can see in the visualization, again, we're getting those green lines, giving data that can be useful downstream for any number of operations. Maybe you want to have two objects that come together and they spawn particles where they intersect. There's a lot of places that it can be used in a useful way. Here's just another example of subtracting these pig heads from the horse. And again, just how consistent and clean that edge is. Something else I want to point out here is that a lot of times Boolean operations are basically A and B, right? You have like one object and you have another object and you're going to merge them together or cut them out. But we actually took a slightly different approach where we can do multiple A's and multiple B's, right? All in one operation. And so you see all of these pig heads, they're not done one at a time, they're actually done all at once. Which means we actually union all of the pig heads together and then subtract those from the other object, the horse head in this case. And that means you can do very complicated things without compounding the errors, which normally happens when you do multiple Boolean operations in a row. Instead, this is all done in one pass, which means there are no errors. So let's take a look at an example that would be useful like in production where you want to break something up. So here I've just randomly taken these grids, I'm just randomly rotating them and sticking them in this object. There's no care for whether all these grids go all the way through the geometry or anything like that. And you can see it's just sort of a ridiculous thing to even try to do to get a clean result. However, the result of this operation is actually very clean. You can see how nicely we've cut up this geometry even into tiny, tiny little pieces. And so really what this does is it gives you the ability to think about destruction in a new way, where you're not sort of managing expectations, you're not using tools like Voronoi shatter and so on. You can just cut with anything that you want. So now shattering something, preparing it for something like destruction is now a completely arc-directable process instead of a very technical process, which is what it typically is. So earlier I talked about how we can just get data from the Boolean node, okay? And so here's an example of using Boolean just as a pure utility. So basically we have the legs of this sort of toy and we're shoving it into the body. And on the right, these green polygons, they're just being highlighted to tell you that if we were going to do a Boolean, this is where it would happen. These would be the polygons that were involved in it. So it's actually just a data analysis. Like we're just saying, where are the self-intersections on this mesh? Highlight them for us so that we can do something about it. So in a more practical example, a very typical task is somebody says, oh, we have to do a simulation on this wall, we're going to break this wall. Can the modeling department build us a wall that we can break, right? And then they send you this, and you're like, awesome, that looks great. And then once you start looking into it, you go, oh, but those pipes, like those are just going through the wood, right? Like they're not, we didn't model holes for the pipes, we just put the pipes through them. Same thing with these sort of cross supports, they're just intersecting everything. And that's fine when you're just going to render this, but if you're going to run a simulation on it, it becomes very painful, right? Because simulations don't like interpenetrations, they don't like things like that. So you could use this purely as a data analysis tool, and when a modeler gives you this object, you can then turn around and say, okay, here are all the places that need to be fixed on this model before we can actually do anything with it. Keep modeling until all that red goes away. When there's no more red, then we can do something with it. And that's awesome. That's just a great pipeline tool, right? Nothing to do with Boolean really at all, except that you can now build a little tool. An artist plugs their model into it and goes, oh, there's some red there. I need to fix those places. I need to cut the holes and so on. But you actually could automate this process as well. So we actually just take that exact mesh and run it through the Boolean and say, you know what, everywhere there's a self-intersection, just delete that piece. And so now we've actually cut all the holes in the wood. We've cut the pipes. We've cut all the self-intersections. So now this is actually just a completely free of self-intersection model that can be just passed down the pipeline to effects, right? So this is like automatic cleanup of very complicated geometry. And now that we know we have this rock solid model, right? There are no self-intersections, this is perfectly ready now to be thrown into a simulation, we can now cut it up and make it look like something that's going to break apart. So let's just look at a sort of a silly example of how we can cut up this wall. So here I'm just animating on all the cutting objects that were used, all in one pass, to cut up this object, and just how truly absurd this is as something to even attempt to run a Boolean operation on. I mean, there's, I think, 3,000 planes or something, it's ridiculous. But again, all in one pass, and the result of that is basically this. We now have wood that looks like it's wood, you have the gyprock cut up into patterns that look more like actual materials, the pipes are cut up in logical ways. And what that allows you to do now is run a simulation that looks like the materials you're actually trying to make, instead of this sort of more generic stuff that you get from other fracturing tools. So let's take a look at a simulation. So on the left is our new Boolean shattered object, and on the right is our Voronoi shattered object. And both of these simulations are pretty cool, like there's nothing wrong really with either of them. But if you look on the right, where we're using the Voronoi tools, you get this very generic shattering pattern, right? Like the wood doesn't really look any different than the gyprock than the side beams. It basically looks like it's all made out of the same stuff. Whereas on the left, the wood looks like wood, right? You see it immediately, without any texture maps, without anything to tell you that's wood, you just immediately see it as wood, right? And that's because you've been able to art direct that shatter to exactly match what's in your brain, like how this wood should actually break apart. And just to leave off, let's just look at a close-up of that. So again, you can see this sort of wood grain splintering effect on the wood versus the more generic Voronoi shattering on the right. And Voronoi shatter is great. Like if you want to create, you know, a million pieces of something really quickly, it's awesome. And you can even do neat wood grain type effects by stretching the noise and doing interesting things with the Voronoi cells. But you're always sort of fighting it, right? You're struggling against it to avoid this look. Whereas on the left, these new tools just allow you to completely arc direct your shatter to look like anything that you want, and be sure that you're going to get nice, clean geometry out of the end. So really, this is the beginning of a whole tool set. You know, a pipeline for destruction in Houdini using these new tools. So it's not just a modeling tool, it's actually a pipelinable tool for modeling and destruction, even just a pure utility. There are a whole lot of other features and options for Houdini in games. You're going to see some other people throughout the day showing like amazing things that people in studios have done. But this is just a quick overview of some of the more interesting tools specifically for game artists. My name is Scott Keating. I'm a product specialist here at Side Effects Software. If you have any questions about anything that I showed, or anything about Houdini really, please come up and talk to me. I'll be around the booth kind of all day long. So thank you very much.